Please do not miss the test on Wednesday. Okay, ready. I'm ready. F of x.
X squared over x squared plus 3x minus 10.
3x minus 2?
10.
Minus 10. Perfect example. What type of function is it? Of course, it's a rational function. Very good. Excellent. Good. So my next thought is this. Because I have to get my table going. And it's easier, instead of writing on several pages, it's easier to just put everything in the table because I need the table to summarize the information so I can easily graph. Okay, very good. Next step. I need a domain. Can anyone give us a domain for this function? Perfect. No factor disappears. I will write immediately. And I will write infinities. But what I don't know is what? What I don't know about infinities is their sign. So let's plug in negative 5.1. I hope you agree with me. There is no need to plug in anything here. Why am I saying that? Why I say don't waste your time to plug in anything in here. Why am I saying that? Because x squared, it will always be positive. Don't waste your time. It would be a waste of time to plug in anything over there. It's always positive. So negative 5.1, this is negative, this is negative. What is the sign then? Good. With negative 4.9, this is positive, and this is negative. With 1.9, this is positive, but this is negative. And with 2.1, everything is positive. You understand that the sign at the top will always be positive and will not affect the result. So I don't want you to waste your time plugging in something that is always positive. Okay, what about the end behavior? What type of rational function is it? Type 1 or type 2?
1.
Type 1. So the leading coefficient is? And the leading coefficient is?
1.
Very good. Can a function with a vertical asymptote at negative 5 and a vertical asymptote at 2 be symmetric? No. So, but I have to write something because the problem is asking me. So I'm going to say f of negative x will not equal f of x and will not equal negative f of x, not symmetric. I'm happy with just this shortcut because then I know you know that there's no way the function can be symmetric if it has horizontal, a vertical asymptote of negative 5 and 1 and 2. Okay, now I want the x-intercept. When is a function 0? A fraction, a rational function 0? Only when? Right. How many zeros will you give?
2.
What does that mean? Multiplicity 2. What does multiplicity 2 mean?
We'll just touch that.
Turn, very good. So 0, 0, turn, don't forget. Because x equals 0 has multiplicity 2. That's all I want you to do with this problem. 2 minutes. 2 minutes. Fill up the chart. You're done. Graph. That's it. Please don't waste too much time on this. Okay, I start with the vertical asymptotes and the horizontal. So this is x equals -5, this is x equals 2, and this is y equals 1. When we graph functions with asymptotes, you must start by graphing the asymptotes. That's mandatory. Okay, I only have a point basically. So now I'm trying to make sense of the information I see, and I'm only looking at the table. The table says the function is coming from 1. So the function is coming from 1, going to infinity. No problem. From 1 going to infinity, that's easy. From negative infinity to where it turns back to negative infinity, that's very easy as well. And on the other side, from positive infinity to 1. Easy. I don't have to determine anything. I don't even have to graph it with a graphing calculator. But let's do it to check. This function has absolutely no secrets. Oh, I have it here. Sorry. Okay, y equals. Because the top has only one term, it's okay with, it's okay without. But you know me. Divided by, in parentheses, x squared plus 5, plus 3x minus 10. Calculator doesn't know, not as smart as you are. We have to put in a second function, y equals 1. I'm going to use the standard viewing window for now. Here it is. Here it is. Here it is. And now the horizontal asymptote. It doesn't matter, but we don't know that. So what this function does, but we don't know it in algebra, we can't. They should have not. Is that a problem from my math app?
That's just an example.
Yeah. So what happens here is the function has a minimum here, and then this is a lot. I'll show you. We'll zoom in. So it crosses, which is allowed. The function is allowed to cross a horizontal asymptote. It will never cross a vertical though. So it comes to a minimum and then comes back and asymptotically. So it does this. So this is the y equals 1. It crosses it to a minimum, and then will eventually get closer and closer to it. But that part we don't know, because we don't have enough tools. Let me show you. I'm going to zoom in there. So between positive 2, the vertical asymptote was at 2, yeah. Between positive 2 and to the right, and I'm going to zoom in and I'll show you what happens. But you don't have to worry about that. But I'll show you because it's here. We are looking at it. So I want to change the viewing window between let's say 1.5, and I don't know how far I should go. I'm going to put 30 for now with a scale of 6. And y minimum not more than 0. Y maximum not more than 1.5. So here it is. I wouldn't have expected that, but it happens because the numerator is x squared, see? So it's crossing the y-axis, not the y-axis, the horizontal asymptote. It's coming to a minimum, and then asymptotically approaches the y equals 1. Crosses, comes to a minimum, and then asymptotically comes closer and closer to 1. You don't have to worry about that. I'm not going to ask for something like that. This is for calculus, not even for pre-calculus. This is what I did in chapter 3 with my students last week in calculus, so don't worry about it. So in order to be exact, I should correct the graph. It actually, don't erase anything. I'm just going to present this. So that portion is the correct piece, not this. Okay, not to worry about. Okay, very good. So we have number 3, but then we have also a polynomial, correct? Okay, so let's do number 3 before that. Perfect. In number 3, we have x minus 5, and we have Krista. Was number 3
Yeah.
correct? Okay. So g of x 3x squared minus 5, and they want us to find f cum g, g cum f, and f cum g of 0, and g cum f, and g cum f of 0. I cannot stress enough, please redo all problems we did in class. Do you think I can remove this? Yeah, I can. Okay. So in order to find f cum g, I will immediately write f of g of x. I will replace g of x by 3x squared minus 5. And then I will look at f that says whatever minus 5. And this is my whatever now. So then I have 3x squared minus 5, and this is 3x squared minus 10. And that would be it. Since I have the function, I'm going to plug in 0, and I get negative 10. Is this okay? Yes? Everyone, is this okay so far? Okay, so now g comp f. So I'm going to continue here because I will run out of room soon. So this is g of f of x, which is g of x minus 5, and which is, I look at g, and g says 3 times whatever squared minus 5. 3 times whatever squared minus 5. And then I write 3, and then I have to expand this. And what do I get?
X squared minus 10 x
Excellent.
plus 25.
Very good. Thank you. Thank you. Thank you. I cannot thank you enough. 75 minus 5. And then g comp f of 0 will be 70. I try to convince my students from day one, but I'm not always successful. And when I am, I feel great. It feels great. Yes, please. Say it again. Number 5. Krista, is this okay?
Yeah.
Number 5. Oh, so I was saying what I would like you to help me with is we all have a job in which we enjoy things, some things very much, some things, and some things not really, right? But they're part of the job and we have to do it. So for me, grading is not easy. This is how I would like to grade. So will you help me achieve my dream? This is my dream. So that it takes me, I don't know, 20 seconds each test. Because if I have to think, okay, there's a partial credit here, maybe I can give 2 out of 5, maybe I can give 3 out of 5, then it takes me like forever. But if you help me, this is going to be very easy for me. So I want you to make it easy on me, and I'll make it very easy on you. So please, can you achieve that for me? This is how I want to grade. 30 seconds per test. And since I talked too much, I forgot what you said. It was number. Okay, yes. So we have, it's right here under my nose. So f of x equals 7x minus 1. They're asking us to determine the inverse function. They're asking us to find the domain and range of both. And they're asking us to graph both on the same coordinate system. Okay. So first of all, I will determine the domain of this function and the range of this function. How do I think about it? First, I identify the function. Once I know what function this is, then I should have no difficulties in finding its domain and range. What type of function is it? Good. So then we know it looks like this. What is its domain and range? I know I look silly, but I like doing this. Right. So it is negative infinity to infinity, negative infinity to infinity. And what will be the domain of f inverse, ladies? And what is the range of f inverse? Right. It's reversed, but they are the same. Because this is part of the question, right? Part of the, and I have to write that. Good. So now is this function 1-to-1? Because I'm not going to try to trick you or anything, but we should always ask ourselves, okay, I'm asked to find the f inverse, but is it 1-to-1? Because if it's not 1-to-1, then I'll have to worry about a few things there. Is it 1-to-1? Yes, the line is 1-to-1 by the horizontal line test. Very good. So then I have y equals 7x minus 1. My next step is x equals 7y minus 1. And the last step I solve for y, so which is x plus 1 over 7. But I have to write f inverse, which is x plus 1 divided by 7. The problem is not asking me to show or check whether these are inverses of each other, so I'm fine. But now I'm also asked to graph both on the same coordinate system. When I'm asked to graph a function and its inverse on the same coordinate system, this is my first thought. Mandatory. Because I know that they have to be symmetric with respect to y equals x. If one of them crosses y equals x, at the very same point, the other one must cross y equals x. Because remember, the points on y equals x are 1, 1, 1, 1, 2, 2, 3, 3. Now, if you reverse those, you still get the same point. So that's my first thought to graph this. So I go back now to f of x equals 7x minus 1. And like always, I try to determine the x and y intercepts. Those are the most important points. When x is 0, how much is y?
-1.
Excellent. So 0, -1 is our first point. Now, for this, I may just need to do some work. That's okay. 0 equals 7x minus 1. 1 equals 7x. X is 1 over 7. So we have two ordered pairs, 1/7, comma 0, and 0, comma -1. So I am going to plot 0, -1. And you can say, how are you going to plot 1/7, comma 0? I'm going to say, very difficult. I'm going to say it's here. Of course it's not. But I'm not going to look with a magnifying glass at your graphs, and I'm hoping you are not going to look with a magnifying glass at mine. So this was f of x equals 7x minus 1. This automatically must be a point that belongs to the inverse function as well, because that's where the function crosses y equals x. That point has the same x and the same y. So now I need one more point to plot and graph the inverse function. Can you come up with another point for the inverse function? Very good. Because if the function passes to 0, -1, the inverse function must pass through -1, 0. Mandatory. Very good. Awesome. That's all I need. So here it is. So this is f inverse x plus 1 over 7. Again, no one is going to look at your graphs with a magnifying glass, but they, as we know, they have to overlap. This piece has to overlap this piece, and this piece has to overlap this piece when I fold the graph with respect to y equals x. Do we have the polynomial, Becca? Oh, I can give you the book. I can open it for you. This is usually just here. Okay, so we want to graph a polynomial function. Any questions on this? Is this clear? Great job. Ready?
Yep. Negative 2x to the third, parentheses x minus 1 squared, parentheses x plus 5.
Very good. Now, this is a polynomial function. It's not rational. It doesn't have a ratio. It doesn't have a denominator. So it's a polynomial function. Now, the first thing we have to identify, of course, the domain, but the degree, because a lot depends on the degree. If the degree is even, the function must look like this, even, or like this. If the degree is odd, it must look like this, something in the middle, of course, right? Or like this, depending on the leading coefficient. So we know that it's polynomial, so this function never gives us any headaches. It's not a square root, it's not a rational. We don't have to think about the domain at all. So I've seen it in the past. Please do not graph vertical asymptotes or horizontal asymptotes for polynomial functions. These are smooth, continuous functions. They are defined everywhere. Okay, so now I have to identify the degree, because the degree tells me how many solutions you will have, and it will also tell us how many, the maximum possible number of turns. It will also tell us the end behavior. The degree tells us a lot. That's why no one tells you this, right? When we study polynomials and we talk about the degree. Why do we need a degree? For this. If I know the degree and the leading coefficient, I know how the graph looks like. That's why we studied the degree, 100 years ago when you started algebra, right? That's what I meant. Nobody tells you why. Why do we need to worry about the degree? Here is why. Okay, ready? Degree. 5. 3 and 2 and 1.
6.
Very good. Degree 6. How many solutions? Or x intercepts?
5.
Okay, you are talking about turns. 5, but solutions,
6.
absolutely 6. Very good. So can anyone x cubed, x minus 1 squared, and x plus 5, can anyone give us 6 solutions?
0, 1,
Right, so 3 of those are 0 with the multiplicity 3. 2 of those are 1 with multiplicity 2, and one of them is negative 5 with multiplicity 1. When you add up the multiplicities, you have to get the degree of the polynomial. And indeed, 3 multiplicity 3 plus multiplicity 2 plus multiplicity 1, they end up to 6. So I have negative 5 first, and then of course 0, and then of course 3, zeros for all of them. But what does x minus 5 do? What does the function do at x minus 5 or x minus 5, 0? What does it do? It's a cross, a regular cross. What does it do at 0, 0? Multiplicity 3. Slow, very good. Slow cross. And what does it do at 3 comma 0 where the multiplicity, how did I come up with 3? I'm inventing stuff. Okay, so at 1 comma 0, 1 comma 0 multiplicity 2, what does the function do there? Even multiplicity. Turn. Okay, we're done. We have to find the end behavior, and it's not symmetric if it crosses a -5 and turns at 1 and slowly crosses at 0. I can immediately write not symmetric. F of -x does not equal f of x, does not equal negative f of x. It's impossible. I don't want to waste my time. Not symmetric. Okay, but I have to establish the end behavior because it's an even degree and the leading coefficient is negative. Yes. Yes. That's it. That's all we need. So I'm going to plot those 3 points. That's a starting point. So 1, 2, 3, 4, 5, 0, 0, and 1. Okay, let's make sense of the information we have, and then figure it out. So from -infinity, we'll cross straight at -5, 0. But it has to turn, because now it will cross very slowly at 0, 0. It has to turn again, because it comes back and turns at 1 and goes to -infinity. One more time. From -infinity, crossing at -5, 0, it turns, because it comes back at the origin and it crosses slowly, but it has to turn one more time because it comes back at 1, 0, turning to go to -infinity. Not a problem. So cross, turn, slow to a minimum, now turning again at 1, going to -infinity. Yes, I have no idea how high these two are, but that's the function for sure. So with a graphing calculator, I have to determine those. So in y equals, clear whatever you have, -2 x cubed, in parentheses x minus 1 squared, and then in parentheses x plus 5, and close. I know the action happens between -5 and 4. So the viewing window, -5 and 4. I don't know how high, I don't know how low. I have no idea. So I see here it's huge. I have a cheat sheet, but you don't have. So it's huge, high up, potentially. I don't know. We'll see. So I'm going to continue and say y minimum, -4, and y maximum, I don't know. I'm just going to put 20 for now and see how far up, because this is confusing here. Okay. Okay, so it's really high, but it's very clear what's happening here. So at least we can take care of that. So it's not a regular cross like this, but it's a slow cross. It comes to a minimum, tiny minimum, but still minimum, and crossing again at 1. So since we're here, I'm going to determine this minimum between 0 and 1. So with second and calc, I want a minimum, which is 3. And between 0 and 1, I don't want to guess, just give me the minimum. And it's 0.61, 0.61 comma 0.39. And now I can focus on the left-hand side. And I'm going to change the viewing window for the y-axis. I don't know. I'm going to say 100. I have no idea. I'll come back and adjust again with a scale of 10. It's not good enough, as you see. Fine. Okay, I'm going to go to 500. Let's see what happens now. with a scale of 50. Still not good enough. Thank you. Fine. This time I'm going to go to 3,000. If you have the numbers, don't torture me. Give them to me with a scale of 500. Does this work? Close. Close. Okay, fine. So I'm going to say 3,400 or 5. Okay, fine. So I know the maximum is between -5 and 0. So go to second in calc, maximum negative from -5. I did something, let me start again. I have a maximum, which is 4, between -5 and 0. And give me, I don't want to guess, -4.1, comma, 3,226.92. So obviously my graph is far from being perfect because that does not look like 3,000 and that does not look like 0.39. So this is not 0.39 for sure, and this is not 3,000. But I'm not really interested in any particular accuracy. I'm just interested in how you visualize this graph. Very good question. Is this better? Perfect. Again, I don't want you to spend too much time on either graph, not the rational and not the polynomial. Okay, next question. Number 13. Okay, number 13, we really don't have anything to do. We did this problem in class from the book. So let's just take a look at it and answer questions. What is the pH level after 36 minutes? You have to read it from the graph. Or you can put it in the function. Put the function in the graphic calculator and punch in 36. So for 36, I'm not sure. I would probably say 4.8 maybe. What is the pH level at the lowest? After how many minutes? Hard to read, but I would estimate 4.5 minimum at 24 minutes later. According to the graph, what is the normal pH level? 6.5. Very good. What is the equation of the horizontal asymptote? But why? It has to be an equation. Y equals 6.5. What type of rational function is this? Is it type 1 or is it type 2? Type 1, that's why it's the leading coefficient over the leading coefficient. What is the leading coefficient of the top? What is the leading coefficient of the denominator? That's why the horizontal asymptote is 6.5. The pH level over time increases without bound. Is that correct? No, of course not. The pH level over time gets progressively further from the horizontal asymptote. That's the concept of the horizontal asymptote. It gets closer and closer, eventually closer and closer. Very good. The mouth pH level over time decreases without bound. Like it goes to negative infinity. No. The mouth pH level over time gets progressively closer to the horizontal asymptote. Of course. The pH level starts at 6.5, then decreases rapidly for 24 minutes. For the remainder of the hour, the pH level gradually increases back to 6.5. Yes, but we still have to read the other two, just to make sure. The pH level starts at 24. Of course not. The pH level starts at 4.6. Of course not. So we can disregard the last two. Very good. Next question. Which one? 12 it is. Yeah, we just had a polynomial function a minute ago. I think we did this last time, though.
Yes.
That's okay.
Did we cover synthetic?
Which one?
Synthetic.
Right, I'm not going to ask you. I didn't present it, but if you want me to show you it, I will.
If it's not gonna be on the test.
No, of course not. Synthetic division was removed from pre-calculus.
That's what I thought.
So I said, well, why am I asking my algebra students? But if you want me to show you an example of synthetic division has limited applicability. It's applicable only when the denominator, the divisor, what I divide by, in other words, is x, not x squared, not 5x, x minus a number or x plus a number. If the denominator has 3 terms, like x squared plus 2x minus 5, we can't use it. So long division is always applicable unless the denominator is just one term. Chris?
Can we do long division?
Yes.
It's the same answer, but it's in my.
Oh, yes, of course.
Okay.
Yes, give me any example you have.
I don't have one. I have a question.
Yes,
It's in half of that.
yes. I mean, you can log in and you can look if you want.
I didn't do them. I didn't know if it was the same answer or not.
Of course, of course.
So if this practice says number 11 says use synthetic division, are we supposed to substitute and use long division?
Yes,
Oh.
but I'm not gonna, I already changed that,
Oh,
because I didn't do it. Of course. I'm not gonna ask you to do something that I have not presented in class. That will never happen. And on Wednesday, before you leave, you can come in early if you'd like to start earlier.
Should we just go over the domain part of number 14
Yes, number 14.
or inside the solutions?
Number 14? Yes. So in 14 we have x plus 7, and we have x minus 9, and we have x plus 5, and this is a rational inequality, and we're asked to find the solutions. So it happens that everything is set up properly, all factors, a ratio, and all factors, and 0 on the other side. So I can immediately use the table with x plus 7, and x minus 9, and x plus 5, and the ratio. X plus 7, x minus 9, and x plus 5. X is the variable in the problem. And how many numbers, x values, I should say, how many x values we have to put in the table at the top? Yes, one for each, assuming they're all linear factors, and they are. They're all linear factors, because if it's x squared minus 9, then I'll have 3 and negative 3. Very good. So then what? In order from left to right. Yes? And 9. So this one has a negative 7, this one has 0, and this one has a 0. But now the question is, what does the ratio do? Because that's very important. At negative 7, the ratio does what? No. What happens on the negative 7?
0.
Correct. Because the numerator is 0. What happens on the negative 5? Correct. Because the denominator is 0. And what happens at 9? Because the numerator is 0. Great job. So now all these have the same slope, so you don't have to think. This is not what I'm promoting here, lack of thinking. But what I'm really saying is that that's a sequence of signs. And then in the first subinterval, we multiply or divide, it doesn't matter, but we have 3 negatives. Correct. On the next one, you don't even worry about the positive. So we can count 2 negatives. And on the next one, we count 1 negative. And on the last one, we don't count any negatives, which means the domain is x, not domain, you know what I mean. The solution of the inequality is this says negative is less than or equal to 0. So I'm after negative. So I'm after this, and I'm after this. But I have to be careful now because the equal symbol asks me to use the zeros, and I will, but I cannot use the -5. So it's between a negative infinity and -7, closed at -7, but open at -5, comma 9.
Someone asked if that's the solution set.
That's the solution set of the inequality, correct? Yes.
Can we take a look at number 4?
Yes. Number 4. Where are you 4? Yes. So in number 4, any questions on this previous one? Yes, please.
Do you add the 9 to positive infinity after that, or are you just looking at it?
Say it again.
Like, do you include like bracket 9 and then positive infinity parenthesis to the
No, because it's just looking for less than 0.
positive here?
I can only include a negative.
Oh, okay.
And 9 is included because 0 is there. Other questions on this? Anyone? So then we have h of x equals the 6th root of x to the 7th minus 4. They want an inner, let's call it g of x, and they want an outer, let's call it f of x.
G of x is
X to the 7th minus 4 is the inner function. Once we have a number,
6.
the 6th root of x. Very good. Excellent.
And that's it.
We're asked to decompose the function into an inner and an outer. And we are asked, all we have to do is just think in terms of if I have to evaluate. If I have to evaluate this function for x equals 2, I would have to calculate x to the 7th minus 4 first. I get 1500, and then I take the 6th root of 1500. I just made up that 1500, of course.
Okay.
Number 8. Any questions on this? Number 8. The midpoint formula is the average of x, comma, the average of y. So the average of x, you add the x values, you get -5, and the average is you divide by 2 because there are two numbers. And the average of y is -15, and you divide by 2 to calculate the average. Is this okay?